Hi class, we're now on chapter 18.7. This is qualitative analysis. So there's two different types of analysis. Qualitative analysis, which is what we're going to cover, is test for the presence or absence of ions, and regardless of their amount. So we're not concerned with their amounts at this point, just what they are and if we can identify them. Quantitative analysis determines the quantity or amount of a chemical substance present, so how much of those ions. And wet chemistry is bench chemistry. A sample containing several ions is subjected to the addition of several precipitating agents. That's what this method is called. There's certain methods that are considered classical methods, and that is a form of analyzing material. So a sample containing several ions is subjected to the addition of several precipitating agents. This is in controlled environments, so they can figure out which is what it is. Addition of each reagent causes one of the ions present to precipitate out. This is when I say classical, because now we have a lot of instrumentation that can do a lot of this stuff. So this isn't needed anymore. So reagents are added in a very specific order to separate and identify metal ions in solution. 5 different precipitation reactions are performed to identify 5 specific groups of metal ions. Precipitates from each group can then be further analyzed to determine the identity of the metal ions present. So let's take a look at that. So in this case, we have group 1. So we have a mixture up here, and we add acid to it. With that acid, the addition of the HCl solution precipitates chloride salts. That means that the chlorides will attach to this and become a solid. So anything that has, if this mixture has any of these, then that's going to be removed out of that beaker of ions, and then it's going to be filtered out. So it's going to be, there's going to be a precipitate, and that precipitate is going to be filtered away from the solution, which leaves us with the remaining solution and any remaining cations in it. Then after that, an acid is for insoluble sulfides. So this remaining solution is then treated with a weak acid, which is hydrosulfuric acid, and it will precipitate any of these out. And once it does that, those will also be filtered out. So this is a group 2 step. So it's going to filter out any group 2, and I'll go over what these groups are. So then what happens is, I know it looks like this is the same, but this is in acidic conditions. This is in basic conditions. So now we're looking at base insoluble sulfides and hydroxides. So a base and either ammonium sulfide or additional H2S is added to the solution. But remember, there's a base to create this basic conditions. The base then drastically increases the concentration of the sulfide, so the ion of this, and the hydroxide ions. If any of these, and let's go to the next slide, so any of these will then precipitate out with any of these cations here. And then whatever is the remaining solution goes to group 5. And here we add, or group 4, group 4. I'm losing my own step here. So group 4 at this point is insoluble phosphates. So this is phosphate right here. So only group 1 and group 2 metals are present in solution. And the group 2 metals, magnesium, calcium, strontium, and barium, all form insoluble phosphate compounds and are precipitated by the addition of diammonium hydrogen phosphate, which I'll show you in the next page. Okay, so then we get to group 5. Group 5 are the alkali ions and ammonia. The remaining ions in solution can only be group 1 metals or ammonium. So at this point, they don't precipitate. They never went through any of the precipitations because there was they were not going to ever precipitate out. So what do you do with these ions at the end? So some of these ions can actually be identified through a flame test. And because we're online, most of you probably didn't do the flame test in lab, in person, and it's really cool because when you dip a wand in these solutions separately, they give off colors. And if you did lab flow, the atomic spectra, I believe, that's what they was trying to show you, is that this is where some of the fireworks, the colors come from. So this is just a breakdown from another one of my slides, and it gives an idea of what's happening. And I think this is a pretty good step breaking down the steps and the colors that go with it, which is nice. Too bad it was in a different book. So this is, again, just breaking down each step that I already talked about. This is insoluble chlorides. It tells you exactly what it's going to precipitate with. And if nothing forms, then none of these ions, are believed to be present. Then the next thing happens with, that was a picture that moved. I don't know why that moved. It doesn't matter. It's in your book. Now, the next step is the acid insoluble sulfides in a weak acid conditions. Then the next one is base insoluble sulfide, so addition of a base like sodium hydroxide, and then diammonium sulfide or H2S, and then it deals with these here that if they precipitate out. Then we have insoluble phosphates, and this gives the information I just went over. And then at the end, these are the ones that did not precipitate out. And then you can do a flame test. You can see orange. If you dip these exactly like I said, you can see that orange goes with sodium. And potassium has this very violet color, and it is very fast. Like you blink, you miss this color. But it is really pretty when you see it. And this will help identify the remaining ions. So let's do a problem. A precipitate formed when dilute HCl was added to an unknown aqueous solution, but no more precipitates formed. So they went through all the steps, and only first step had precipitate. The remaining precipitation steps of the qualitative analysis process. What conclusions can be made about the species present in the original solution? One of the more ions that form insoluble chlorides precipitated upon the addition of HCl. So it must have been a chloride attached to one of these in the first step. But what that means is that because no other precipitations happened, you must not have had any of the other ions available or present in that solution. So the only thing that could be left over is the alkali metals, which would not precipitate out. Okay, so let's do a review. Qualitative analysis tests for the presence or absence of chemical species. Quantitative analysis determines the quantity, how much. There's 5 different groups of metal ions: insoluble chlorides, acid insoluble sulfides, base insoluble sulfides, hydroxides, insoluble phosphates, and group 1 ions. Can be selectively precipitated based on their solubilities with different anions. Precipitates from each of these groups can be further analyzed with specific tests to determine the identity of the metal ions present. That's it.